Today's session is going to be on identifying and protecting sensitive data with privacy code scanning. I'm the chief scientist here at Privado. So we'll be having a session now, and the goal is to understand what is this new thing called privacy code scanning and how can you identify and protect sensitive data with this. Today is May 12th, 2023, and this is me, your presenter as well as a host in this webinar. I'm Suchakra. I'm the chief scientist here at Privado. I have a PhD in computer engineering from Polytechnic Montreal, and I used to be the first person in a company called ShiftLeft, which is also now called Quiet.ai, and have like 6-7 years working in cybersecurity. This is my venture into privacy, and it's amazing. So what we'll be discussing today is on your right here. So why is it difficult to keep track of sensitive data? What is sensitive data itself in applications? And, what is this new angle that we are looking at, when we are talking about sensitive data now? And what is proactive versus reactive approaches to privacy? Privacy is absolutely essential. We all know that, but what is the proactive approach versus the reactive approach that is there these days? And are there any ways to embed privacy into product development? As you keep on developing products, rapidly these days. How can you embed privacy as you're developing them? We'll move on towards a small demo of the tooling that we have here at Privado for privacy code scanning. And towards the end, we will have a question and answer session. You can keep on asking me questions, no worries. So about Privado very quickly, we are a privacy platform for the era of proactive privacy, because it's the time when privacy has to be done very early on and embedded in the development process. So we are the first platform that's doing this, founded in 2021, backed by top VC firms. You can see here, Sequoia, Insight, Emergent. And we have some very amazing customers like Hair Technologies, which is in mapping and geolocation services. And then we have Headspace, we have Thrasio, Zigo, these companies that have been helping us, and we are building for them. And, it's going great. So why is it difficult to keep track of sensitive data? You can think of it from multiple perspectives, but being a scientist myself, I will say that it's actually code that is producing a lot of data. And our approach towards, protecting sensitive data or protecting sensitive data leaks from happening is something like this right now. So on one side, we have code. It's like a faucet is turned on and it keeps on producing a lot of data. The data is spilling, on a floor. And on the other side, we have privacy operations, which have a broom to clean that data. But that's not going to happen because, you're trying to clean water with a broom. To go more deep into it, this is how this code would look like. So on the left, you see a small snippet of a real piece of code that we were analyzing once. So you can see here, we have get customer data by username function, and it has username coming in. And we know that, this is coming from a user. So user is interacting with your application. They're putting in their username. And it's eventually going here. And all the way down, we see that it's getting logged. So you're logging this username directly inside your logs. So what would happen when this application like this runs in a real life is, there will be 500 customers continuously engaging with them, and it will be producing 500 new data elements. It's just one line of code. It's going to produce hundreds of data elements. And then they will go in all these multiple databases all throughout your application deployment in your infrastructure, wherever it might be. And you might not know, there might be some log scraping services which are scraping logs in one of those databases, or even some third-party log scraping services which might be there. And towards the end, it might be some innocent humans, some DevOps person who is just looking at the application and they start seeing these customer usernames and their details inside those logs. So you didn't intend it to happen, but what happens is that the problem really lies inside the code. While privacy operations folks would try to look at databases, look at the log scraping services, look at infrastructure, what is going on where, try to create a data lineage, and then spend months doing it. But essentially, you can see that the problem lies very early on. It's a single line, and a developer who wrote this absolutely understands what is happening. So this is why it is difficult to keep track of sensitive data, because the generation and movement of sensitive data is happening through code in reality, and going in multiple places, while privacy operations folks are trying to look at many places. So if we just all looked at code very closely and very carefully, we might be able to solve this problem of sensitive data tracking. So let's see much more in depth horizontally across the services how this affects you. So data processing is distributed. So there are many apps, many microservices, many APIs and data pipelines through which data comes in, goes out, and moves in real world. It's not just a single application and data is going in one database. It's going everywhere. So since it's very distributed, it's very difficult to keep track of it. And we empathize with privacy folks who try to do that. And the second thing is that the nature of how applications are being developed right now is very different. So data flows are changing continuously with each release. Then the speed of development is too high. You have 20 developers, and they will suddenly one day start collecting multiple data elements inside your applications, and you won't even know it. By the time you would start tracking and doing audits, it would already be too late. So this introduces the issue where it becomes impossible to implement any sort of privacy by design, because the code changes are happening very fast. And then there is any lack of governance. You might have some contracts, you might have some policies which are set, but none at an engineering level. It is set very high level. Hey, we all are going to agree that we don't collect precise location. Okay. But then what do you mean by precise location? In what context can you collect it? In what context you cannot collect it? So there are all these nuances when an application developer is developing the applications, that the high level definition of what we should do is not in sync with what is exactly happening inside the code. Whereas this should be there. When someone says that you should not collect your precise location and not send it to a third-party advertiser, it should be provable inside code that this is exactly not happening, or it is happening, so that you can fix it. So because of all these issues, it becomes very difficult to keep track of sensitive data, but there's a solution to it. And if you don't keep track of your sensitive data, you will end up in one of these headlines. So one of the things that I remember is an issue with Twitter recently, I think in 2019, where they were using this two-factor authentication, phone numbers that they were collecting as part of two-factor authentication. And someone in their team inside just looked at this nice collection of two-factor authentication phone numbers and thought that maybe we should use it for advertising. And that was a big mistake, because there was a regulation. You should not use it, the data collected in one area in another area. But their application started doing that, and they never even knew about it. So I think this is one of the cases where it becomes very difficult in large organizations. So you will end up in one of these headlines essentially. So this is a critical issue that needs to be solved. Exact definition of what is sensitive data, and understanding where it goes inside the code. So to fix that, we introduced this tooling called privacy code scanning. So privacy code scanning only looks at your application. We don't need to look at anything inside your databases or any connections in real world, how it is deployed. All we have to do is just take the application, We scan the application, and then we would be able to discover and classify personal data. We will have complete data flow visibility from the start of the data element inside the code all the way towards the end, whatever the end be, like interesting syncs that would be there inside the application. So this allows us to find and fix privacy and security issues very, very early on. So, just scan the code, you will understand what data is there, classify all of that data inside the application, and then start tracking where it goes inside the application and where it is exiting from the application. This allows you to monitor and continuously have privacy compliance as part of the development process itself. So this is very deep in nature, and this is also a way in which you can have provable privacy. So why do this? There are many ways you can implement, privacy inside your applications, but one of the ways that people have been using is try to look at data from a data store level. So for example, DSPM tools, data discovery tools, you will have to hook into the databases, try to understand what data is there. And what if you even find data there? So suppose you find PII data inside those databases, and then you will look up what is your schedule. Okay, we should not have retained this data, and you're going to clean it. But that doesn't solve the issue, because who is responsible for putting data inside those databases? It's code. So until and unless you fix this very early on at the source code level, you would never be able to catch up on what kind of data is being stored where inside the databases, because that's more a reactive approach that we see. Another way is like process level. So you would actually manually have processors where you will see we have a regulation that we would not do this, we will not collect it from this app, it will never be shared there. So these are actually point in time data maps. You will one day sit, in 4 months, you will complete a map of what happened to your data throughout the deployment, throughout the application, throughout the journey of the data. You will be able to map it. But then it's already stale because the code was being developed very fast. New data was added continuously. So the clear way to do it is at the source code level, which is proactive privacy. As code is getting developed, you keep on finding whether it's going to leak data. Yep, easier said than done, but it's doable. So why it helps you is there are three buckets in which this helps you. One is compliance. So you can always have data maps and your assessments always up to date. So for example, just by scanning the code, you can have automatic robot generation. You don't need to manually look at each and every point inside the code. You can map it whether it really is compliant with the GDPR, CCPA, and such high level policies that are set for your application. You can have that piece completely taken care of without even going at the data, looking at the data, or looking at the databases, just by looking at the code, because you know how the code is going to make the data flow. So you can completely have a good data map directly by looking at that. Other is finding and fixing shadow data flows. So this is, again, a similar example of Twitter that we had. So, they were collecting phone numbers for two-factor authentication and then eventually sending them for advertising. So these kind of shadow data flows, you can find them. So look at the data inside the code, see if it's going to some interesting third parties, interesting, like SendGrid, AWS, different S3 buckets somewhere, or, services that you didn't even know about. So, for example, some SMS sending services, you might not know that you're even using that, but one developer one day decided to implement that so that they can send SMSs for advertisement. Okay. And then, that's kind of like a data flow that should not be there, but it is now embedded inside the application. You will keep on having this sensitive data getting leaked. Another cases which I really want to point out, and I have seen in cybersecurity also, one of the biggest reasons is sensitive data leaks directly going to logs. So people think that it's fine, and developers really, really like to put printfs, they like to put logging statements. That is interesting. I mean, it is part of the development process. But what happens is when the application runs, these logs go to many third-party services throughout the system. They get scraped, they get put into another system. So for example, folks might be using Logstash, Loglead, different kind of applications to just manage these logs. And they all get scraped just by, everything that you do, like error logs, info logs, debug logs, whatever you put there, data is definitely going to go there. And it ends up in unintended places where it should never have been there. You have an application running in Europe, and you have logging statements applied to it. And then there is a logging service from US you're using, which is scraping the data, and the agent is even running in EU. Everything looks fine. But then the data gets scraped and sent to an S3 bucket residing in US. So now your sensitive data, which should have been there, is now somewhere else. It clearly violates issues like GDPR, and you might not even know it. That's exactly what these shadow data flows are. So, that's the thing, like reducing the risk now by finding and fixing shadow data flows. The third part is for much more advanced organizations who know what they're doing. They are already doing PIAs, DPIAs. It would help to scan code very early on so that they can embed privacy directly inside the code. So they would know, they would have guardrails so that, if a developer suddenly introduces a new collection point inside the application, collecting a precise location of a customer, you can have guardrails using privacy code scanning so that you can detect when this was happening. Okay, so I think it's time for a demo, and let's switch to demo mode. So this is what the dashboard looks like when you first start running Privado. You have, you would just be connecting your GitHub repositories. They would, look something like this. You have a setup, you connect your GitHub repositories. Once the your GitHub account gets connected, you will start seeing your repositories here, and the scan starts automatically. So the scan starts, and as you see the scan happening for each of these repos. So each of these repos here are one single repository directly on your source code management solution. So let's look at one of them. So when you click on one of these repositories, that's how you would begin analyzing your application. The scan has already been done, and data and any inference from the scan has already been made here. So the first thing you see is the data diagram. So here you see the blue ones here is account write, accounts read. This is database. So this means that from the app, some data was going to databases. Here, the data was going to some logs here, and then these are collection points inside the application. And these are interesting. So these are third parties where your data is going. So you clearly first see the data map, right then and there. So that's the first thing that you see. Then we have a data elements view, which shows that, it's a high level view of your application, what kind of data elements this application is handling, what kind of data elements this application is collecting. Let's dig a little bit deep into it. So you click on the data elements tab, and this is the classified data. We looked at all the data already, and it has the Privado system and the scan has already classified the data accordingly. So we see email address, last name, date of birth, etc., being handled by this app called as Privado Accounts API. And then the interesting part here is the data flows tab. So this shows that this last name is going in multiple places. It says that the last name might go in SendGrid, collections, etc. You can start clicking on it. So we'll start clicking on email address. Let's see. Let's consider that we are interested in knowing what is happening to email address. So the first thing that you see is this data flow diagram. It shows you a complete flow of email address getting shared to Slack, SendGrid, getting stored in a database, getting leaked to 9 log consoles, info log, and then also getting processed in 5 instances. And an interesting part here is points where this email address actually gets collected inside the application. Makes sense. Authenticate and sign up other places where you would be collecting email address from a user. The magic now is also you just don't get this view, you get an exact proof of what happened throughout the application. So in this case, we have a place here inside the application where a sign up was there, and we see that the sign up has email in it, and Privado started tracking sign up. So we start tracking sign up, and this becomes a source. We keep on tracking it throughout the application one by one, just the same way a developer was writing it. And we eventually see that it becomes part of a message. This email gets added to this big message, and it becomes a Slack message. And we see that this message gets added and then eventually gets sent to Slack via client.send. So it's a complete proof that you get of your data flow throughout the application. It helps developers and engineers fix these issues proactively. Privacy folks can go back to their developers with an exact proof of what is happening here. So same in like console log. We started tracking mail. You have some mail ID that we started tracking to, and eventually it goes to request, it comes to response, and then we are printing out the response. It might, okay, in this case, it's just the status code, but we might be printing a lot of information in that. So same with many other approaches here. So you can keep on going through it. So collection are the collection points inside the application. So we started collecting login here. Because we know what is inside login ID. We know that login ID contains email. So we started tracking login, and we know that this login is going to request body, and it is part of this authenticate route. So we clearly know that inside the authenticate route, you would be sending your email address. So we can have this level of granularity. And with this information, a lot can be done. So the first thing that you might already be thinking is that your data assessments are taken care of. So here, let's see, you want to run an assessment with a developer. You have all this information, very difficult to understand. So you can create a new assessment and then send a new assessment to your developers. So you can send an assessment like this. So let's see, you want to send an assessment for here. You click send assessment. It asks you for which developer you want to send it. You can select owners also for the repository just by looking at the top contributors which are there. You can have that. You can send an assessment to any developer or engineer inside your organization to ask them whether the data collected is correct or not. So let's see how they look. So we click on one of the assessments here, and right out of the bat, you see that there are some things which obviously have to be written manually. Okay, what is the purpose of this application? What application category this application belongs to, who owns this repository, name of new owners, etc. This is standard stuff that you need to do for GDPR kind of ROPA reports. But the crux here is this. So it takes, anywhere from like 90 days to, 6-7 months for people to just get, accurate information about what is getting collected inside the apps and get it fixed. But here we directly give you this information. So you can see email address, the developer can just click on review. They go through these and they check them. Yeah, this is correct. This is not correct. This is correct. This is not correct. They can go through all of them. And once that's done, your report is complete. And whenever the scan happens next, new code comes in, a new scan happens. Whenever that happens, you're going to have like an always updated ROPA report. So this is one of the core features, having up-to-date assessments all the time. It reduces the time from 5-6 months of assessment going back and forth with the developers to just having them always on. These assessments are there. Someone asks you, do you have your reports ready? You click export and the reports are done. Then we have pieces about policy. So you can have like policy, for example, like no PII data outside of the UK. You can create a policy like that. So where you can go through the data elements, you can select that the data elements should not be application usage, photo recording, or any of the sensitive data categories. And anytime a developer pushes a code, for example, if the data element is let's assume it's medical certificate. So if our application detects that, if our scan detects that the developer started collecting medical information, we will create a Slack message to them or a GitHub comment to them saying that, hey, you have started collecting this. You will see this notification inside policy. An issue would be created for such. So for example, here is an issue that was created. So in this issue, you can clearly see that there was issue. There was an issue where mobile app was trying to access users' exact location. We can clearly see that there was a precise location which was added here. There's an occurrence here. You can clearly see this is where the developer started to access find location inside the application. This caused a violation because the policy was set, and because of that, this issue was created, and now an assessment was sent to the developer. And developer, we are awaiting responses from the developer to tell us why they started collecting precise location here. You can keep on adding comments, what is going on, what's the status of this, and see who is assigned to it. So there's a whole workflow around privacy issues that can be created if a policy that you have gets violated. Then reports, we have seen always up-to-date ROPA reports. No need to go back to your developers. Just have to click export and we are done. And then new amazing features like contract scanning. For example, in this case, assume that you were using you have a contract with Salesforce. And all you have to do is to just dump this PDF into the contract scanning that we have, and it will look literally at the exact contract. So this is like a real contract with Salesforce. Very difficult to understand what Salesforce says they're doing with the data. But with this, you can clearly understand that these are the data subjects, their employees, agents, advisors, freelancers, and then what kind of data is Salesforce going to collect, and why are they going to process it? So we see title, position, first name, last name, and then what security measures do they have in their organization for that? So for example, regularly monitors compliance, they maintain an audit program. So you can have a nice high level understanding of what happens. Another piece that we have is consent compliance. So in this case, we have, suppose you have a website, you can just add this website, and then it will tell you whether it is compliant with the laws in Netherlands, Germany, UK, and what is getting collected here. So for example, no consent is added here when a cookie is put. So that's clearly not great. Then you can have reject all, essential only cookies here, and then advertisement specific issues. So for example, you have network request compliance already, and this is fine for Netherlands, Germany, and UK here. So in all these geographies, we are compliant with the way cookies are getting collected. We are compliant with the way advertisers who might be are collecting this. So we have this whole set of features that are just discovered first by scanning the source code, and then you connect it with the allied things like contract scanning and consent compliance, and you're able to see like a whole holistic picture of what is happening in your privacy inside your organization very early on. So all the applications, what are they doing, what data was collected, what data is getting leaked, where it is going from, and all the way to interesting points inside the application. So you can get like a very complete picture of that. With that, we are probably towards the end, and I would invite any questions and answers throughout this. So if you have any questions, there is a Q&A section inside this. You can start writing them there, and I would be willing to answer them. Okay, so I think I have one question here. How do we define sensitive data? That's super interesting. So what you saw here in this is a nice classification of sensitive data, where for example, let's take the email address. We started tracking this email here, get email here, and then categorize it as email address. So similarly, for this, we have almost 200 to 300 rules on how to classify sensitive data. They go all the way from basic stuff like email address, phone number, to mental health records and stuff even inside it. So for example, you have building access code. We have a categorization for that and a way to detect building access code also. So we have a large big classification of data that we do, and that's the core feature. We understand what exactly is going to be sensitive or not, and the way we classify that. So it does not just depend on scanning and looking at this email string. That's not what it is. In this case, for example, as I was showing in I guess like here, we are tracking sign up. So sign up is the stuff that we are tracking, not email, because we understand what is inside the sign up object, and we know that there's email inside. So we'll start tracking sign up, and we will keep on tracking that. So even if you name this ABC, it will still get tracked. So there are these complex ways in which we classify and define what would be sensitive data. Let me look at other questions. Okay. Is there a backend? So for great demo, thanks, Jim, for the question. For consent compliance, is there a backend legal rule finder that interrogates and understands the regime-specific laws and regs? So we are building this piece where we would be able to match what would be the specific law and all the way down towards the source that what you have, the backend that you're calling as the legal rule finder. I don't think we have that yet. Yep. Thanks. Yeah, we'll have one more minute for any questions that you want to put in. So you can go on the Q&A section on your Zoom and start asking the questions there. Yes, so good question. So I think one question from Sandeep is that the scanner looks for keywords such as uname, username, etc., to figure out and flag a name as PII. But if someone names them as UN, UNM, it won't find. So dev team needs to have a discipline when naming. So again, just to remind that we don't look at only keywords. Yes, there is a component for us to look at just uname, username, etc., the common ways that developers would write, but it just doesn't only have that. What we do is what we do is you can name your variable as ABC, but if it has a type, again foo, but if it inside foo type you have something which is sensitive like email, username, etc., then we will track all the way to ABC and I'll track all the way to foo. So we understand what is sensitive in what context, and then we decide to track it. It doesn't matter that you need to really name it, uname, name, etc. Another point I would say is that having seen like millions and millions of lines of code and worked on static analysis, I can tell you 98% of the time developers are going to use similar nomenclature based on their geographies. They might change them one by one, a little bit here and there, but they will definitely be using them. And we have a very nice way to catch all of them. So we really do a very good job in detecting and classifying sensitive data. Another question. So how do you deal with variances where data elements may be sensitive in one jurisdiction, but not in another? How do you assign regime-specific nuances? Very good question. So we do have this, big data classification set, 200 to 300 way of classifying, but all of this is completely adjustable. So which means that there is a little bit of YAML that needs to be written here and there to reclassify them, make them less sensitive, high sensitive in one geography and another geography. We have customers who work in Europe as well as US, and they do it normally in their systems, changing the classification and sensitivity for different kinds of data. So I guess like one more minute for any other question that is coming in. Okay, so I guess we can call this as a wrap. If you have any other questions, you can always mail me at suchakra@privado.ai. That is SUCHAKRA at privado.ai, SUCHAKRA at privado.ai. And you can ask me any deeper technical questions. I'll be willing to help you on that. Okay, that's a wrap then. Thanks a lot, everyone, for attending this. Have a nice day.